I'll record on my computer. All right, yeah, we're recording now. That's perfect. And thank you very much for the introduction. Daniel, if you would like to give a brief introduction to yourself as well.
Sure. Well, I'll try to give it along similar lines to what Denise said in terms of travels and where I've been. I grew up mostly in Cork. I was born in the north of Ireland, but I mostly grew up in Cork. And I was a undergraduate at UCC back in the days when there were only 2 or 3 students in each year in the physics department. Quite a long time ago now. And then I went as a graduate student to California, to Caltech. And there so before I went there, actually, after I finished my undergraduate degree, I did a master's in UCC with Neil Moroku, because at some point as an undergraduate, I realized that general relativity sounded very interesting and that we were very fortunate in Cork to have an expert in the area, very distinguished person. So I asked him to do, if I could do a master's project with him. And at the risk of going on too long, just to give you an idea of how much times have changed and how people like Denise and I are maybe just old enough to remember the end of a different era. When I then mentioned to the then head of the department that I wanted to do a master's with Neil, he said to me, well, of course, if you want to do a master's, that's fine, but I'll decide who you're working with. Because that was the old days, you know, in the old days in a department in Europe, certainly the head of the department, the professor, you know, they ruled everything. Anyway, in the end, he didn't seem to mean that he was going to prevent me, but at any rate, I did do a master's with Neil. And then I went to Caltech for graduate school, and there I was luckily able to continue in general relativity working with Kip Thorne, and I was very interested in history of science. In fact, I'd even thought about trying to switch to history of science when I applied to graduate school, but I didn't really know how to do that, so I didn't. And then I got to the United States, and of course, I suppose presumably things are a little different in UCC today, but back when I was a student, you know, there weren't any actual choices. Once you'd picked your major, you know, your subject, then there were pretty much the only certain classes that you took. And I like to tell people that I took everything from physics to math, including math physics. And that was the breadth of my education. But obviously in the US, they had all these subjects and you were allowed to sign up for different things. And I thought, oh, I'll take a history of science course. And I really enjoyed it, got on very well with the professor, and thought, geez, I'd love to do a little project on that. And I went to Kip and said to him, well, would that be okay if I did a bit of a project in history of science? And instead of telling me to get out of his office, like I think most physics professors would, he thought about it for a week and he said, here's a project idea for you. So that got me started in history of science. And in fact, my first postdoc was in that area in Cardiff in Wales. My wife was a postdoc in Oxford at the time as an astronomer, so I spent a good bit of time on the railways. And then I went back to Caltech for a while, again doing history, because I joined the Einstein Papers Project, which works on publishing the collected papers of Albert Einstein. And so I did that for a couple of years. But in both places, I was very fortunate that there were strong relativity gravitational wave groups, so I was able to continue also doing physics research. And then I was able to follow my wife to Arkansas, which is where she's from. She got a job as an astronomer here in 2003. And I followed her and eventually was able to get on a regular position here. And that's where we've been ever since.
Perfect. Alex, if you want.
Yep. So both of you are working in fields associated with astrophysics. What was it about astrophysics that inspired you? And did you ever think about working in other fields that were perhaps completely different? I suppose, Denise, if you'd like to go ahead.
I don't really remember what got me interested in astronomy and astrophysics, but I know that I was interested from a pretty young age, like probably before I could actually pronounce astrophysics. I was interested in other things too. I was interested in science in general. And I know certainly when I was an undergraduate in the US, you have a major and a minor subject. And and they could be anything really. My major one was physics and my minor was astronomy. So I was kind of keeping it in mind as a possibility, but keeping other options open. And the same thing when I went to do my PhD. I went to a place, it's a bit of a different system in the US. You don't normally choose your project before you go. You sort of choose a place where you think there's a couple of projects you might like, and go there and then see how things pan out. So I went someplace that had interesting projects in both physics and astrophysics, radio astronomy. And at the end of the day, you know, when I passed all my qualifying exams and I had to find a supervisor, the radio astronomy group had money for me and were delighted to take me. So that sort of set my course. But, you know, I suppose if they hadn't had any money, I might have wound up studying liquid crystals or positrons or something like that. Those were two of the other groups that were interesting.
Right, thanks, Denise. And Daniel?
Well, I probably, like Denise, I definitely remember being interested in astronomy and astrophysics from an early age. And I think it was that interest which got me motivated to study physics in college. As I mentioned, I had a strong interest in history as well. So even when applying to universities with my CAO, is it still called CAO?
It is, yeah.
Yeah. I thought, well, should I do history? Should I do physics? And I thought, you know, I feel like I can read a history book by myself, but I don't know that I can really learn everything I would need to learn in physics by myself. So I'm going to pick that one. But at some level, it wasn't as close as that makes it sound. But I did always have a feeling, you know, I could change my mind. I might, you know, I want to do physics to know that I understand it. And I don't know that I viewed it completely as a career. I just found that I kept having to do more of it to understand it properly. I didn't really understand it really until after I'd finished graduate school, to my own satisfaction. So at some level, I viewed it, yes, as a career of study in the literal sense. And doing the research was a necessary part of learning enough to feel like I actually knew what the hell was going on. But a big part of it was that I did enjoy it. You know, there were of course aspects of it that weren't as enjoyable as others, but I did find that on the whole I did enjoy it. And I was very lucky, of course, because I did have this interest in the history side, but that turned out to be something I could combine largely just by incredible good fortune, really. No planning on my part. I just asked people if I could do it and they said fine.
Perfect. Thanks, Daniel. Now, you've both mentioned that it was quite a bit different back when you were trying to make your way into the physics world. What was the biggest challenge of your career, just trying to break into research?
Well, okay. Two things come to mind. One was that one of the differences about the system here and in the US is that in the US it's generally considered, or often considered, that a graduate student should find their own project, whereas here it's often the case that at least a kind of a broad framework for a project is in place and a student sort of gets assigned to that, and then the details kind of develop according to the student's interests. But you know, I was at Brandeis University in the Boston area, and I had passed all my qualifiers and I hooked up with this radio astronomy group, but they had the idea that I should find my own project, which, you know, finding a topical, interesting thing to work on having to do with magnetic fields and active galactic nuclei jets when you barely have started to learn about them is not an easy thing to do. So I was actually, it was quite a tough, I'd say probably about 9 months when I really had serious doubts as to whether, you know, whether I could manage this, because I was just floundering like a fish on a beach, and my supervisors seemed completely oblivious to the fact that this was going on. And then at some point, we were getting some new data, and I got sent out to the very large array in New Mexico to look after these data being taken. And I was still in this sort of pretty miserable state. But I was learning more and more about what my group was starting to do. We were the first ones to actually make the type of measurements we did. So I was out at the VLA, and there was an elderly Australian astronomer there. And we got chatting together, and he was polite. He asked the young graduate student, "So what are you working on?" And I told him we were working on high resolution polarization measurements of AGN. And he said, "Oh, that's very interesting. Do you have any data for OJ287? And I said, "Well, yes, we do." And he said, "Well, I predicted what kind of magnetic field structure that should have. I wonder if you observed it." And I said, "What kind did you predict?" And he told me, and I said, "Oh, that's the kind we observed." So that was the miracle that set me on a positive course and got me where I am today. Because I went back to the university and I said, "Guys, we have to stop stalling publishing this stuff. We've got these great new data, and we've got people out there who've predicted that you should see what we see, and our data are showing it. Let's go and write a paper." And bless him, the next morning, my supervisor had left a paper, partly written paper, on my desk with me added as an author. And that was the first paper that went into my PhD. So that was a happy ending, but that was a really challenging time.
Well, I suppose I can echo Denise's experience that, of course, the beginning stages of research can be very difficult. Obviously, almost by definition, you don't yet know how to do it. And I think one of the things that, obviously, people who are interested in doing research on the whole are relatively rare birds. I think it's probably fair to say that the experience of having to do something that not only do you not know how to do it, but nobody has really done it before, not that precise problem anyway, is, I think, a potentially very uncomfortable one. And I suspect that most people wouldn't fancy it at all. And there are a few who thrive on it. And I suppose most of us at least need to have, as Denise just described it, the feeling that before we really can relax that, oh, okay, that did seem to work out in the end. I did seem to figure out what was going on. And I suppose that's true, that getting over that initial period when you have no idea whether it'll work out and whether you can do it or whatever is difficult. And it is true that being able to talk to people, having people to collaborate with can be important. And it is a factor to consider if you're considering research and considering graduate school, and when you're at a graduate school, picking a group to work in. I think it can make a big difference that there are other people to talk to. Maybe the group isn't just you and a professor, but there are, the group is bigger. Maybe there are postdocs, maybe there are other graduate students. And that can help because obviously it's these little things that provide a spark that, or a connection that can push things along. And the more people you have that you can talk to about it, probably the more chances of that happening. That certainly was my experience. I benefited from being part of a research group. Now, and just to give you an idea, obviously when I did the master's in UCC with Neil, it was just him and me. That was it. But luckily we got on well and we did talk a lot. And of course he's exceptional. So, but even then, the experience of talking to other people still mattered because when Neil presented it to me, well, it was natural for him obviously to focus on the technical side. That's after all what I had to do. He had to explain to me what I had to do. And also he might have said more, but I don't know that I took it all in, And so there was some level in which I didn't really understand what I was doing. It was to do with closing a little loophole in Birkhoff's theorem, which is about showing that the gravitational field of a body will be this spherically symmetric stationary thing, And so for a long time, though, I didn't really understand it. I was trying to grapple with the formalism. And the trouble was that I would go around Cork and I'd meet people like former teachers who would ask me what I was doing now. And I'd say that I was studying physics. And of course, that was great. They thought, oh, although of course there's that, famous bit of advice that you get if you've ever talked to more senior physicists, that if, for instance, you're at the dentist and they ask you what you do for a living, don't tell them you teach physics till after they're done. Because invariably they'll tell you, in the United States, they would have been obliged to take a physics class, and they'll invariably tell you, oh yeah, that was my least favorite subject in college. So, or I remember quite a well-known chap once put it to me. He said, listen, if you're in a cab and you don't want to talk to the driver, tell him you do physics when he asks, you know. But if you do want to talk, if you do feel like talking, tell him you study black holes or astronomy or something like that, and then you're in business. So anyway, there I was. People would say, what do you do? I'm studying physics. And then unfortunately then would come the moment, if they thought they knew a bit about physics, they'd say, okay, what are you doing in physics? And I'd say general relativity. And then there were the hardy souls, like an old teacher that did say this, who would then press further and say, and what are you doing in general relativity? And then you take a deep breath while you thought about trying to explain what the Birkhoff theorem was. And I finally realized, after this had happened only 2 or 3 times, I had to come up with a better way to explain what I was doing. And it was only at that stage, believe it or not, that I thought in physical terms about it. And I realized, oh, if it's a single body and it has this spherically symmetric stationary field at some distance from it, what that means is there's no gravitational waves there. That's really the only logical thing that would be out there far from the source that would be disturbing the stationarity and the symmetry. So what I'm really doing, because what Neil had me doing was closing a loophole that nobody had ever checked if a Lorentz boost, you know, violated Birkhoff's theorem. And a Lorentz boost is just an accelerating mass. So I said, what I'm really checking is, does an accelerating mass necessarily radiate gravitational waves in the same way that an accelerating charge necessitates transmitting electromagnetic waves? And 2 things happened then. First of all, people smiled and nodded when I said this to them. And second of all, I knew what the hell I was supposed to be doing, and it went much better after that. And of course, and you know, we even when we wrote the paper, obviously we put that in because. So yeah, so even there, just the experience of talking to anybody was helpful.
Thanks, Daniel. Denise, you've spent quite a large part of your career studying active galactic nuclei. Could you just give us a brief explanation as to what that involves? And are there any questions that are still left unanswered there that you really love to know the answer to?
Yeah. Okay, you know that the matter in the universe is organized into galaxies. You know, our galaxy is the Milky Way. And the matter in galaxies, if they're spiral, it's sort of in a disk. If they're elliptical, it's a bit in a kind of an ellipsoid shape. And it's now known that in the centers of probably all galaxies, actually, there is a supermassive black hole. So it's a black hole with a mass of, like, for example, our galaxy has one with about 10 to the 6 times 10 to the 6 solar masses. So 6 times 10 to the 6 times the mass of the sun. And our galaxy is fairly beefy, so that's a fairly large supermassive black hole by galactic standards. But there is a class of galaxies that have super massive black holes, more like 10 to the 8th, 10 to the 9th times the mass of the sun. So there seems to be a process of accretion of matter onto these black holes. And in the course of this, and it's probably not 100% proven why, but it's widely believed to be due to electromagnetic forces, matter sort of comes in, swirls around in an accretion disk, and when it comes towards the black hole, electromagnetic forces actually shoot it out along the axis of the black hole into so-called jets. And so these jets are basically streams of plasma, streams of charged particles that are moving away from the center of the galaxy at relativistic speed. And there are magnetic fields that are local. And whenever you have charged particles moving in magnetic fields, it turns out that they give off radiation. That's something that Dan actually referred to. When a charged particle is accelerated, it will give off electromagnetic radiation. And so these jets give off what's called synchrotron radiation, which is detected in the radio. So it's really quite cool because the galaxy might look, well, it might look a little bit interesting or it might look fairly boring in the optical. But when you look at it in the radio, you see these huge plumes of plasma showing up at radio waves. And that's the synchrotron radiation from these charged particles moving around in the magnetic fields in these jets. So that's why it's important to study these guys in the radio waves. That's how I got into it. And my specialty is doing high resolution observations with very long baseline interferometry, which means using a whole array of telescopes around the world together to try to increase the effective diameter to be able to see finer detail in these jets. So at this point, I've almost forgotten the question, but I think that probably more or less answers it. What about these objects is outstanding, and I'd really like to know. I think it would be really cool. One of the things I work on myself is this mechanism. What is it that actually launches these jets? And we're one of the few groups actually doing observational work on this. And I think we're starting to move towards an answer, but it would be really exciting to get that be really conclusive. And the other thing is that there are a bunch of different types of active galaxies. And it's often not clear what makes them different, but there are suspicions that are things like the spin of the central black hole, or whether the central black hole and its accretion disk are spinning around in the same direction or opposite direction, and things like that, the accretion rate onto it. And it hasn't really been determined how these things combine to give a particular flavor of active galaxies. So I think that would be really cool to sort out.
Perfect. Thank you both for those answers. We had one or two general questions then on research for both of you. So do either of you collaborate with other universities or departments on your research? And if so, which ones? Daniel, if you'd like to.
Sure, yes, I do. I have, of course, one has students that move on to other places and have postdocs, and it often happens that one has occasion to continue collaborating with them. I currently have a student who's at the University of Wisconsin in Milwaukee, which is an important center for gravitational wave research, LIGO especially, and he has just moved there, although actually one of the things that he's working on there is actually another method of proposed method of detecting gravitational waves called pulsar timing. So that's very much a radio astronomy kind of a thing. The basic idea there is a gravitational wave that passes by the Earth will not only distort space, it will also alter time. So your clocks might run a little slow. If you're looking at pulsars, pulsars are, of course, keep quite regular time. Every so often, though, there may be a glitch. But if all the pulsars on the sky glitched at the same moment, then that would probably be because a gravitational wave passed by the Earth and glitched our clocks, not their clocks. So it would be a way of detecting gravitational waves here on the Earth. So that's something that he started working on, and I'm wondering if I should, try to be involved in that in some way or another, given the connection there. I have a colleague who I first worked with when he was a graduate student in Cardiff. I mentioned that I was in Cardiff as a postdoc, and he was a graduate student there. He's Greek, and he's now in Spain. And so I regularly Skype with him, usually on a Friday. So hopefully tomorrow morning I'll talk to him with my students. And I suppose there are others, mostly in the US. But I do have some ambitions. There's a group in Dublin that works in extreme mass ratio inspirals, as they're called, which is an area that I've worked in, which is to say those supermassive black holes at the centers of galaxies that Denise was talking about, they also, of course, occasionally swallow things like smaller stellar mass black holes. And it's easy enough to model, theoretically, such a system of the smaller black hole inspiraling into the big black hole. It's inspiraling because as it whips around pretty quickly, if it's close, it emits gravitational waves, and the energy it loses causes the orbit to decay, and eventually it'll disappear into the big black hole. Such a system would eventually be detectable by a proposed space-based gravitational wave detector called LISA, which the European Space Agency hopes to fly in 10 years from now. And this kind of research would be important for that, and there's a group in UCD who does a lot of work on that, and so I've had some kind of ambitions to kind of connect with them a little bit. I've been to visit once or twice. So yes, so those I suppose are just a few examples.
And same to you, Denise.
Yeah, I do. There are people in various places with whom I collaborate. I'd say at this point, the most prominent ones are probably at Purdue University in in the US, the Academy of Athens, and the Instituto Astrofísico de Andalucía in Spain. But I also have two former students with whom I expect to be working. Well, either am working or expect to be. One is Sasha Pushkaryov, who's in the Crimea, and the other is Shane O'Sullivan, who just got a faculty position at DCU. So I expect to be working with both of them as well. And this it changes with time. You know, if you were to have asked us 10 years ago, I'd say our answers would have been a little bit different. Yeah.
I'm going to congratulate Denise on her excellent pronunciation of Spanish place names. I mentioned one of my colleagues is in Spain, and we have a Spaniard in our department here. And so I mentioned, oh, I've got a colleague in Spain. And he said, oh, where? And I said, it's in the south of Spain, Murcia, I said very ignorantly. And he looked a bit nonplussed for, I would say, probably a good 5 or 10 seconds. And then he said, Murcia, and went on to tell me how his family were from there originally. And so I said, okay, thank you.
I imagine you were at probably a bit of a disadvantage if his family was from there.
Yeah.
Do you have any advice for researching and publishing a paper? And I suppose more generally, what experiences have you gained from publishing throughout your careers? Dan, if you'd go first.
Sure. Yes, it's a good question. Well, as Denise says, that, you know, she made an important point, you know, that there comes that moment when you just have to realize, yeah, I have to publish something, you know, get something out there. It's tempting. And as an advisor, I often make this mistake with my own students to think, you know, we could do a bit of work. This could be better, you know. My advisor used to like to quote what he claimed was a Russian proverb. He also, like Denise, has excellent Russian and spent a lot of time in Russia. And he said that in Russia, they say, the perfect is the enemy of the good. You know, there's no point in putting things off too long. You know, after all, you know, you can always write another paper later, but nobody's going to know about it. It can't be of any help to anybody if you don't write what you know now. And that is something that I think, actually, I don't know that I could say that I struggled with it, but I do have to remind myself that both for me and for my students that sometimes it's time to write the paper and get it out there. So that's a lesson that is useful. And I suppose also for me, because I publish in different areas, I'm interested in history. Obviously, you publish that in a history journal. Or if you know, and I do some stuff that's closer to astronomy and some stuff that's general relativity, so it's very mathematical physics. These get published in different places, and I'll often find myself having to ask others for advice. You know, where would you recommend that I publish this? Again, talking to people, asking questions is a good idea. You know, it may be that there are grounds for preferring one journal over another, and sometimes they're very practical matters. Some journals charge page charges because they don't earn enough selling the journal to people. Obviously, most people don't buy scientific journals anymore. And so maybe you don't have the money to publish in one journal, but you do in another. And so I do often find that it's useful to ask people for advice on where would be a good place.
Perfect. Denise, do you have anything else to add on that as well?
Yeah, I would very much agree that really, you know, if you've got results, nobody's going to be able to get any good out of them if you don't actually get them out there for people. And this was something I felt really keenly when I was working on my PhD and in the years afterwards, because we really, for a while, were the only group in the world doing what we do. So if we didn't get the results out there, nobody was going to have them. So I really agree with that. You know, there's no reason to put things off. I think it's also really important to try to write clearly, really try to write as if you genuinely want your audience to understand what you're doing. Don't worry that you're making things too simple. You know, it will really be beneficial in the end. And like one of my most vivid memories of my postdoc in Calgary was when I actually went to Ottawa to give a colloquium. And it turned out that, I mean, the type of object that I was specializing in at that time was called BLAC objects. And it turned out that a couple of the people in the audience were actually two of the people who had discovered these things like 20 years before, which completely freaked me out when I found out that those two big names were in the audience. but it turns out, they were working in a government institution and they hadn't really worked on it in a long time. And one of them came up to me afterwards and said, "That was a very nice talk. Thank you for not trying to impress us by baffling us." And that really stuck with me. The idea that just try to be as clear as you can when you write. And actually, listening to Daniel brought back a memory of my very early career when I was still a PhD student. I actually got interested in publishing a couple of papers on physics education. There's a American journal called American Journal of Physics, I think, AJP, I think that's it. And so while I was working on my PhD, without consulting with my supervisors or anything, I actually wrote a couple of papers, one on relativistic effects in active galaxies that are relevant for, that many of you have learned in PY 2106, superluminal motion. If you haven't taken 2106 yet, you will at some point. And some electromagnetism stuff. And it was a cool moment when my supervisor, I'd given him a CV so he could write references for me applying for postdocs. And here were these two papers that he had never seen before. And that was kind of cool.
Those are a very good piece of advice. Thank you both. One of the other questions we had then was, did you notice any significant culture shock when moving country? And would you recommend moving country to undergraduates, or I suppose people going into postgrads, postdocs, things like that today? If either of you want to take it first, I don't mind. So Daniel, if you want to speak back and forth.
Sure. Well, it wasn't too big of a culture shock, I suppose. I mean, obviously, I was going to a country that spoke English, so I was coming from a largely English-speaking country, and I do feel sympathy for people who Denise can talk about being in places where you don't speak the language and where the culture is very different. I had actually spent a little time in Canada as a kid. My parents and my family emigrated and then moved back to Ireland when I was in elementary school. So in many respects, it wasn't a culture shock at all. If people talked about kids they'd seen, programs they'd seen on American TV when they were kids, I usually knew what they were talking about. So that wasn't too much of a culture shock, I think. I suppose there are differences, of course, in the educational systems. But by and large, they were positive ones for me. I mean, obviously, the fact that I was able to go take a history of science class, which I wouldn't have been able to do at UCC for any number of reasons, was a nice change of pace. Still at that stage, I think it's fair to say, I'd had that experience where the head of department in UCC had told me, well, I don't know that you're the one who gets to choose who you work with. Certainly, the culture that I experienced in graduate school in America was, waiting for you to make up your mind and pick a school of what you want to do. So that was nice. So yeah, I largely, I suppose I had a positive experience. I don't remember this. And of course, then I was in Wales, but Cardiff seemed quite reminiscent of Cork. I mean, obviously it's not that far away culturally or distant.
Thanks. And Denise, the same for you.
Yeah, I would say I've had a pretty positive experience as well. Moving to Canada was, it was very similar to the US in a lot of ways, but infinitely more sane in others, like having a national healthcare system and having university education that was affordable. I really enjoyed my time in Russia. It's a very gregarious culture, and it just suited me down to the ground, really. And I think, coming to Cork, it felt very comfortable, really felt very comfortable. And one of my most vivid memories coming here is just being delighted at how kind of relaxed and laid back people seemed. When I came, it was a time when euros were first coming in. And so everybody, anytime you were buying something, people were like looking through their coins, trying to find the right ones. And everybody was taking ages to get the right change out. And I just have this vivid memory of, being in a queue and, waiting to pay for my coffee and sandwich or whatever it was. and finally getting up to the front, and like everybody else, kind of, you know, going through my coins and trying to get the right ones. And the woman behind the till just said, "It's okay, take your time." You know, after having had 5 people in front of me taking ages to get her their money, and I thought, God, this is civilized. This is the way to live, you know. And going to the post office, the first Christmas that I was here, and wanting to send lots of people presents, and going to my local post office and with this big pile of parcels, and you could tell that your woman really felt for me, because she knew it was going to be, you know, adding up to a good bit to spend on it. And she'd weigh it, and it would be just a little bit over a boundary. And she'd say, you know, 2 grams, what's 2 grams? You know, you can hardly, it's a sneeze, you know, we'll chance it. And she put in the lower price, saved me about 10 quid. So really, really pleasant memories of early times in Ireland. And I still think, I mean, things do change, but I still think it's a little bit more laid back than many other places, and I really value that.
Nice. I'm glad to hear you both have positive experiences of moving. We had 1 or 2 other specific questions, and I suppose before kind of got into some of the teaching aspects. But to Daniel, you're a science historian as well as a scientist, as you've mentioned. What do you enjoy about your work that's common to both new research and about learning about research in the past?
Well, there are a lot of similarities and synergies, I suppose. I recall that my wife, who's an astronomer, actually was quite impressed that I guess maybe I'd been talking to her about this, you know, that I felt like, because I was doing my history of the same subject that I was doing my physics research in, that of course I read a lot of older papers that maybe I wouldn't have read if I was just a young physicist. Maybe this is just good advice to read the literature, but obviously I was obliged to read the literature from a historian's point of view. And I think it did broaden my understanding considerably and helped me understand the subject that I was studying from a research point of view much better. So that was certainly synergistic. And then of course, a good part, since my research from a historian point of view is not of the distant past, but recent scientific history. So gravitational waves have only been around for a century. So obviously that's recent. And so some of the people that you are writing about their work are still alive. So an obvious thing to do is to interview them. And so I've done a lot of oral history interviews. I'm still doing them. And except at the moment I'm doing them all on Zoom, because I don't get to travel to go meet people, which works out pretty well for me. And that was a great experience, actually, because, of course, it was very advantageous to my career because I'd be meeting these distinguished people who could help me out. And my own Russian experience actually relates to that. I went to interview John Wheeler, a very famous relativist, who incidentally wasn't an easy person to interview. He wasn't really interested in the past. But he wanted to know what was happening now in my group, and he was quizzing me about that. Anyway, when I arrived in his office, he was dictating a letter to the organizers of a conference in Moscow in honor of Andrei Sakharov, famous man. And obviously, he had obviously refused an invitation to go, and they had asked him, well, who do you think we should have? And he was trying to come up with names. And I'd walked into the office. He said, well, excuse me a minute, I'll finish dictating the letter to the secretary, and then I'll be with you. And so he finished the letter by saying, and you should have Daniel Kennefick come and talk about the history of gravitational waves. And several months later, they did actually invite me because they obviously thought, we've never heard of this guy. I was a graduate student at the time. But Wheeler says we should have him, so I guess we better invite him. So I got to visit Moscow. My advisor got the money together, and I didn't, of course, get to stay there a long time as Denise did, but it was a very, very interesting and pleasant place to visit. And another example of meeting a distinguished physicist, Herman Bondi, he gave me advice, in fact, that's very similar to the one that Denise was given about, you know, don't try to blind your audience with science. They'll appreciate it the more if you are unafraid to be clear. He said that he was once the president of the Royal Astronomical Society, and he found that young researchers confronted with a very distinguished audience couldn't help but retreat into incomprehensibility. You know, they wanted to present their best stuff in a detailed and technical way and show they had the mastery of the details. And he said people were baffled in the audience. So he said he finally took to giving advice to people before the talks and say, please remember that you are going to be speaking to some of the most distinguished astrophysicists in the world. So you must remember to address them as you would a 9-year-old child. And so I guess that's similar advice to what Denise had.
Perfect, thank you. To Denise, you've been involved quite a lot with APONA, the Ecophysics Opportunity Networking Academia, over the past few years. So, I mean, are you encouraged to see organizations like this and such women in STEM nowadays? And more generally, what would your advice be to women who are starting off their career in physics?
That's a loaded question because I actually have extremely mixed feelings about these types of organizations because I understand that at the minute there are probably artificial barriers to young women, well, probably to people in general going into areas that they're interested in. And it may be a little bit different for women and for men, what those areas are. And I kind of understand that something probably needs to be done to try to break down those barriers. But my own inclination is to look forward to a time when you just don't have to worry about this anymore. And I think we need to be careful not to get stuck in a rut of getting so caught up in trying to promote, for example, women being able to go into science, that we somehow lose the bigger picture and forget to look forward and be able to envisage a time when we just won't have to worry about it. So I don't know if that makes sense, what I've just said, but I always have kind of mixed feelings, like if somebody were to ask me to give a talk to a bunch of secondary school girls or something about that, because I simply refuse to tell them to go into science. I mean, in my view, you can see me getting up on my high horse here actually. In my view, telling a bunch of young girls that they've got to go into science is every bit as bad as telling them that they've got to go off and get pregnant and get in the kitchen, right? The whole point is that I would really like to see a future where these artificial barriers are gone, and a young person who wants to go into science and has the ability to do it can do it. A young person who wants to go and become a kindergarten teacher and has the right skills to do that can go off and do that, regardless of what their sex or background is. So that's sort of where I'm at. I'm kind of happy to help a bit with the process, but also looking forward to a time when the process isn't needed anymore.
Definitely, that was quite insightful. So thank you for that. One other question specifically to Daniel. So you're an author of Traveling at the Speed of Thought and more recently, No Shadow of a Doubt. So what was the process like researching material for your books in the early stage of drafting? And I suppose, how does that compare to publishing a paper?
Well, yeah, of course it takes a lot longer. But books are a common way to do things in the field of history, but much less so in physics, obviously. But at the same time, the first book was, of course, nothing really more than my PhD thesis. So having gotten really involved in this project, this history project on the history of gravitational waves that my advisor had recommended, and then I had another advisor then. I'd mentioned I'd taken a course in history of science from a woman called Diana Buchwald, who later became the person in charge of this Einstein Papers project that I mentioned. So she said, well, she'd be happy to advise me on the history side, just as Kip was advising me on the physics side. So that was very fortunate. And so that grew to the point where it was like a second thesis. I had my physics thesis, and then I had this other thing that didn't really get me anything in a, degree sense, because Caltech doesn't do history, but at the same time it was just as big. And obviously a natural thing that a proper historian would do is turn their PhD thesis into a book. And so at the end, after a few years, I decided that was a good idea. And yeah, it's a long process. Obviously I had done most of the research as a graduate student. I had added a bit to it, but typically you do need to improve the writing somewhat from what you hurriedly threw down for your thesis for the publisher's benefit. So it was, I suppose, several years of work. And even just the nitty-bitty of doing a book, you know, it had pictures, and I had to be the one to go get the actual images, you know, that were high resolution enough to use, and get the permissions, and I even had to pay the people if they wanted money for their scans. And and doing the index, boys, those were a lot of work. I can certainly remember that when I finished the first book, I said, well, I'm never doing that again. And they say the experience, this is not the same experience, but they do say, yes, that it's amazing that a woman who has to go through labor and, you know, give birth ever does it again. But I suppose after a while, the memory fades. And I decided, because of the centenary, that second book is about the 1919 eclipse expeditions. And so their centenary was last year. And so I had, when I worked at the Einstein Papers Project, we were doing Einstein's correspondence of 1919, and so I got interested in the eclipse because, of course, he was reading and writing letters about this famous event, testing his theory. And so at that time, Diana, who I mentioned, said, well, why don't you research it more thoroughly? You go off to England and get in the archives. And that was a very nice experience. That's my favorite part of being a historian, actually. The interviewing people isn't quite nice too, but being in the archives, seeing the paper, seeing the things that these people wrote down in their letters is quite fun if you like that kind of thing. I can still remember Eddington, Arthur Stanley Eddington, of course, was one of the leaders of this expedition. And on an earlier eclipse expedition, he'd been to Brazil. And the ship that he was on was called the Arlanza. And so, you know, when you're writing your letter, you put the name of the ship you're on instead of the name of the place you're on. So he had Arlanza. And I was reading this letter, I saw that name, and I spent a lot of time in Cork as a boy in a house called Arlanza in Turner's Cross, which my aunt owned, which my father spent a lot of time in growing up too. It's kind of a family house. And it was called after this ship. The original person who owned the house, her brother had been on this ship in World War I. And so it had a real connection, you know, that sort of thing can be sort of fun, seeing these little historical things that you know something about. So I really enjoyed doing the research for that. And eventually I realized that I had a lot of material that I'd never been able to fit into papers. And the centenary was coming up, and so I decided I'll write a book. I had an ulterior motive too, because I realized it was about time that I could have a sabbatical. And of course, if I told them I was writing a book, they might let me have a sabbatical. And I decided I'll do the sabbatical in Cork, and it'll be a chance to go home. And I had a great time being in Cork for a while, and so it worked out.
Nice. Alex has a few last questions just in general about teaching.
So I've got a few more lighthearted questions to end off with. So what's been your favorite module to teach and why? And do you prefer to teach first years or final years? Or I guess third years too, I might as well ask, seeing as a large majority of us here are in third year.
Yeah, maybe I can start out with that. Interestingly, I don't think my favorite modules are astrophysics. I think my favorite ones actually are probably first year, like PY 1052, 1053. Because there's just so much rich fundamental physics in there. And, you know, the first time I taught PY 1052, you know, when I was in the middle of writing lectures and stuff, I was like, how did I ever pass this course? I didn't understand all this stuff. And, you know, you sort of delve into it and you think about how to put the lectures together, and it all comes together, and it's lovely. And I also really enjoy the second year thermo, the PY 2104. And I'd say another favorite module of mine would be the third year E&M, PY 3103. I taught that for a number of years before Owen O'Reilly started doing it. And again, it's all really good. It does have connections with astrophysics, but mostly it's just really good, interesting fundamental physics.
And the first year modules give you a bit more of an opportunity to show off cats as well, it seems.
Yeah,
so
absolutely.
That's always a bonus.
The first years will tell you, I've been just been going mad with this online lecturing and trying to find some way to give some light relief. So it's quite a challenge, quite a challenge, but I'm
Getting
doing
very
that.
familiar with Murty.
What was that?
We are all getting very familiar with Murty, and we appreciate it.
Yeah.
Daniel, so do you have opinions on that? What of your modules that you do teach do you most like to teach?
I'm curious, so are your guys' classes all online at the moment? Are there any?
Yeah.
Ours are kind of a hybrid. I think most of them are probably online, but there are some which are everybody can be online if they want to. There are some where you also have the option of being in the room, not all of them. So that's interesting to hear. But I guess you guys are on like phase 5 lockdown at the moment, so I guess there's no option. Yes, the first year classes here, I quite enjoy teaching them, but they're so huge. There's hundreds of students in them, so that's a bit difficult for me. So I quite like second and third year classes, especially, you know, after you've done the 2 freshman classes, then the next 2 in the sequence, I quite like teaching them. I feel like everybody else is gone and it's the physicists, you know, okay, there's some engineers or whatever too, but you know, they obviously have an interest. And it is very exciting to be with people who are just getting to grips with the subject and try to help them out in terms of good techniques and ways of tackling the subject and learning how to calculate. But it probably would be fair to say that I get a great deal of enjoyment out of teaching the upper level classes and graduate level classes. At the moment I'm teaching a graduate level, but there are some undergraduates in it on general relativity. That's always a lot of fun. Next semester I'll teach an upper level class on cosmology. I really enjoy that one. And occasionally they let me off the reservation to teach a history of science class, and I also always enjoy that when I get the chance. And so most recently, because I'd written this book on eclipses, and I'd learned a lot about other eclipses, not just the 1919 one, while I'm researching it, I ended up deciding to teach a class on the history of eclipses, scientific study of eclipses. And so that actually was very enjoyable.
Thanks for that, Daniel. So retrospectively, what's the funniest or most embarrassing mistake you've made either during your research or while lecturing?
You know, I was thinking about that and nothing stands out. And I don't know if that's because I've never done anything genuinely ridiculously embarrassing, or if it's happened so often that I just can't distinguish any one particular thing. So I don't think I can answer that. I think the thing to do would be to ask some of the third and fourth years if any incidents come to mind.
I feel like that could be dangerous to throw to the floor, possibly.
I think if James is here, perhaps he might have a few when it comes to volunteering for some things in first year. Spinning around on a chair with some weights comes to mind.
Ah, yes. Ah, yes.
For context, James in our year is renowned for volunteering for physics demonstrations in our modules.
Well, I do have a story of slipping up while lecturing. I'm sure I can come up with lots of stories actually, but this one seems the most obvious to relate. An error that got into the Los Angeles Times newspaper, if you don't mind. So I have a real knack for this sort of thing. So I gave a lecture at Caltech during my second stint there when I was working with the Einstein Papers project. And I was doing this research about the eclipse expedition. It was in its early stages, but it had advanced enough where I could give a talk. And I went over to the place where all the infrared astronomers hung out. They were the ones who had invited me to give the talk. Well, I got unexpectedly, first of all, I got an email from Kip Thorne, Nobel Prize winner, my former advisor, unusually kind of saying, Dan, do you mind if I come to your talk? And I was thinking, why do you need to ask me? You know? I said, of course, that'd be great. And then I got an email from a Los Angeles Times journalist who said, I'm going to be following Kip Thorne for a profile in our magazine around that day. And is it okay if I come to your talk? So I said, sure. So now I knew why Kip had checked with me about coming to the talk. So then came the talk. There was Kip. There was the journalist sitting next to him, very nattily attired. And I gave the talk. And in the middle of it, I made an error. I was talking about the Mercury perihelion advance of Mercury. You may know it's one of the three canonical tests of general relativity. I won't go into the details except to say that I got mixed up, and I quoted the amount of this famous anomalous perihelion advance as 0.43 seconds of arc per century. Obviously, I got confused. You know, I was going to say 0.43 seconds of arc per year, but it's usually quoted as 43 seconds of arc per century, and I fell between two stools. Well, as soon as I said that, a fellow in the front row put up his hand and said, "That doesn't seem possible to actually measure. Are you sure that's right?" And I looked at it and said, "Oh, I suppose it must be 43 seconds of arc per century." But I didn't want to get too flustered. And I said, "I'll think about it a little bit, and why don't we come back to it at the end?" But I did, as any young person, I was still a fairly young person, would do. My advisor was in the room, and I appealed to him. I said, "Kip, do you remember?" And he said, "Well, I don't remember," he said. So at the end, I returned to it as promised. And Kip put his hand up and said, "Well, I've calculated it in the meantime, and it is 43 seconds of arc per century." So I thought to myself, okay, that's making it into the to the newspaper anyway, because obviously that was too good to pass up, right? This newspaper man was thrilled that he was sitting next to this genius who could do the back of the envelope calculation to correct his dumb student. And in the paper, it was a double whammy because he said, Kip and went to this talk, and Dan Kennefick dressed incongruously in shorts, as he put it, because I'm famous since I was a small boy for always wearing shorts. If I stood up now, I'd be wearing shorts. I'd be like Ming the Merciless. Short pants, obviously, not the underwear. Anyway, there I was in my shorts. Now, I was thinking, wait a minute, mate. You were the one who was dressed incongruously. We were in Caltech. Everybody there was casual. You were the only one dressed in a suit and tie. So incongruity was you. Not mine. That was yours, not mine. But then, of course, you told the story about my embarrassing error and Kip correcting it. So yes, I've actually made the newspapers for my mistakes.
Thanks for that, Daniel. I'm sure that must have been a very embarrassing moment, but also it gave a good laugh at the end.
It was good, yeah. I was happy to be in the newspaper. I mean, I didn't really mind being the butt of the joke. I thought it was a nice way for the newspaper to get to tell people exactly how smart Kip was. So I thought, you know what, I'm happy to be the straight man for that one.
All publicity is great publicity as well.
Yeah, that's right.
Yeah.
So I think finally, before we open it up to the audience in case they have any questions, Denise, you're possibly famed in UCC for some of your analogies you use in your classes to describe different physics things. You like your cats, you like your ice skaters. So what's your favorite analogy that best describes a physics related concept?
Yeah, I think the one that has to be nearest and dearest to my heart at the moment is that what I do in my research is mostly look for observational evidence that the magnetic fields in these outflows from the centers of galaxies are actually helical in shape. And it comes about basically from the combination of the outflow and the winding up of the accretion disk. And so if I'm talking to somebody who doesn't have a lot of science background, or even who does, one way to describe this in a way that, you know, not saying spiral or helical, just say, well, it's kind of like the jets have a magnetic field that's in the form of a slinky. And that seems to work. And actually we have a slinky in our lab, so you can actually take a look at it and bend it and see how the magnetic field lines behave when they're straight or bent or twisted or whatever. So I think that's probably my favorite at the minute.
I myself actually mistakenly broke a slinky of Stephen Fahey's in first year, so I have some bad memories when it comes to slinkies being used as analogies.
Well, I'm sorry to hear that, Alex.
Daniel, how about you? Are there any analogies you like to use?
As it happens, my first book on the gravitational waves deals an awful lot with the use of analogy in the history of science, because of course gravitational waves became an idea because people saw an analogy with the electromagnetic field. Once they said, well, this electromagnetic field theory of Maxwell's works great, could we do the same thing in gravity? And it was natural then to say, and then by analogy, could there be something called gravitational waves which play the analogous role to electromagnetic waves in Maxwell's theory? So I thought a lot about analogies, and I devoted a huge amount of space in my book to talking about them. those, of course, are more formal analogies. But I think Denise and I have something in common in liking lighthearted analogies with everyday life. I don't know that I can come up with anything better than mention that here in Northwest Arkansas, we are close to the world headquarters of Walmart. And I don't know if there are any or many Walmarts in Ireland, but you may have heard of Walmart. And Walmart has a sort of an offshoot called Sam's Club, which is like a gigantic cash and carry. Do they still have cash and carries in Ireland? It's like a place where you as a retailer can go, but get kind of a sort of a wholesale thing. You know, it's not.
Yeah,
really
we have some of those. Yeah.
And so Sam's Club, of course, I always tell them when I'm talking about quantum mechanics, you know, that the point about Sam's Club is you can go there, but you're going to get 50 rolls of toilet paper, not one roll of toilet paper. Right? So things come in packets, and you don't get any less than that. So since that sort of is a local touch, that's apparently the best I can do in terms of blending in with the locals. That's an example of a fairly homely analogy that I do find myself using a lot.
Well, I think slinkies and packs of toilet roll are probably a good way to end the our section of the questions. If anyone has any other questions that they'd like to ask our two guests, then if they could either, I suppose, unmute, or if they send in the chat, we could ask it for you. And give a minute in case anyone wants to.
Are you guys able to hear me?
Yeah.
Yep.
So what's an example of certain skills that are useful for physicists, but that we don't really tend to learn at university? And how might we, say, learn them?
Oh, that's a good question. I think we've already referred to some of them. Just the idea that you really do want to try to be able to explain what you do clearly, and have good writing skills, so that you can have a well-organized paper or book and have things written clearly. And I don't know that you really get that in university, because you're not taking any courses where you need to write essays or something. What do you think, Dan? What skills do you need? Where would you get them?
I mean, that is a very good one. And here in America, they're more conscious of that. I mean, they do have a right, in order to make sure nobody gets out without writing an essay, they do have this writing requirement at the very end that everybody has to fulfill. And it is an important skill, and definitely, you know, being able to explain things. I suppose, of course, often enough, at some stage in your career, you might be asked to, when you're still a student, maybe a graduate student, you know, you might be asked to do TAs, and I think that's a valuable experience too, obviously.
Yeah, we actually have quite a few of our third and fourth years doing demonstrating for the first year labs, and also even doing a little bit of tutoring.
Yeah, that was true when I was at UCC as well. So I was wondering if that's still the case. Yeah, I think that is certainly valuable experience. That's the way it was presented to me. I can remember I was very work shy, and I can remember the professor telling me, "Well, you'll be doing some TAing," and I said, "So I just want to make." I said, "Listen, I don't really need the money, so if it's just for the money, I don't necessarily want to do it." And he said, "No, it's not for the money; it's for the experience. So do it."
Communication skills are really important as well, and just being able to explain something that it could be a relatively complicated idea, but in as simple a way as possible.
Mm-hmm. Yes, those are things that are important, and it's hard to know where to go to get them, since that was part of the question. And incidentally, it's different in different fields too. I mean, because of course physicists, maybe as Denise says, don't get as much experience writing things down, but at the same time, they are called upon to orally describe what they're doing. And a big difference between going to a history conference and a physics conference is that at the history conference, everyone will read their paper, right? They will have written it out, and they will get up there with a sheaf of pages, and they will read to you what they have written. Whereas in physics, that would be considered eccentric, and you're supposed to have slides, and obviously there's figures and tables you might be displaying, but you're supposed to be able to talk to some extent extemporaneously. And I think that's a good skill. Sometimes I find the history conference is a little stilted because everybody is just reading, and there's less to, I mean, it's not like they can't speak and people ask questions and then there's to and fro. Certainly the experience of answering questions is a very good one. It's good to ask questions and it's good to answer questions. And I can remember one person, a physicist, talking to me, colorfully describing, he was talking about another physicist who he said liked to think into an impedance. So, you know, explaining something that you're thinking about deeply to somebody else can be a very good exercise.
Are there any other final questions in the chat? I'll give it 30 seconds.
Yeah, I have a question. Have either of you ever been in a situation where...
This is a question
Oh, hold on.
for Daniel. So did you
Hold on.
study
James.
your
James, you're cutting up.
at UCC? And if it was, what degree stream did you go into?
I think James probably got a little cut up. Jacob, do you want to ask first, considering you were in there first?
Oh, okay, thanks. I just wanted to ask, has either of you ever been in a situation where you've published a paper only to find very soon after that someone else has published on the same topic but with entirely different conclusions?
No, I don't think I found that. I have had an experience where we were doing some new measurements that were not particularly easy to do, and the sort of analysis of the uncertainties was not very firm yet, and we were publishing results, but it wasn't entirely clear. I mean, we made our best guess at what our uncertainties would be, but some other people did similar measurements, you know, other objects and other things, but they came up, they had a completely different view of what the uncertainties were. And they thought they were much larger than we did. So that was a bit of an awkward situation because, you know, in our view, we had significant results, and in their view, it was just noise. So we had to, it was pretty painful actually for a while because they were pretty obnoxious about it. But at the same time, it spurred us to do some computational analysis that showed that it was actually statistically significant, you know, trends that we were seeing, and it wasn't just noise. So it had a good ending in the end. But that's probably the closest I've come to that.
Yes, on the physics side, I don't know. I haven't really had it exactly like that. And indeed, in general, I've nearly, in some ways, striven to be in areas where I felt I didn't have to worry about being scooped and, you know, pick problems that weren't so much of general interest that everybody was working on them. I certainly encountered lots of stories of people being scooped or nearly scooped. And of course, I've definitely come across cases where from the historian point of view, I'm often deliberately asking people just this question, you know, because of course, at some level, controversies can often lay bare how it is that science really is done in practice. And certainly on the history side, for instance, what interested me in the 1919 eclipse expedition was I was very unhappy with some of the history papers and also what some physicists were saying and astronomers were saying about the role of the 1919 eclipse expeditions. And the people were almost at that stage that I started working on it kind of saying, oh, it was a fraudulent thing and that they had, you know, fudged the data and all this. And when I looked at it, I thought this doesn't make any sense at all. And sure enough, I mean, by and large, when I put my point of view, other people kind of nodded and said, well, that sounds convincing. And since then, there's been more work that I think people have kind of realized, yeah, the earlier allegations made against these people like Eddington in 1919 were unfair. But, you know, there certainly was one paper that came out right away that said, oh, you know, he's not making a convincing case. And I didn't even bother replying. I didn't feel it was a kind of a paper written by a philosopher. And I thought, yeah, what he ends up saying is, yeah, sure, I take all his points. Everything he says about the history is fine, but philosophically speaking, it still doesn't change the issue. And I was going, well, I don't care about the philosophy, so it doesn't bother me at all.
Perfect. James, do you want to try asking the question again? I know you're in the back arse of Clare, so it may not come through, but you can give it a go.
Can you hear me there?
Yep.
Yeah, it's going through now.
Okay, I am literally at the side of the road here in Data, so if I get cut off, you know why. So it's just to Daniel. So when you were at UCC, were you here for your undergraduate? And if so, which stream did you decide to take?
I don't know what is a stream.
Yeah, I think life was very different back then.
Yeah, I mean, we have different options now for different types of physics you can go into.
Right.
So you can do joint honors and astrophysics specifically and stuff.
Right. No, there was none of that. There was physics, and that was it. Yeah. Well, it was experimental physics and math physics. Are there still two different departments?
Yeah.
Well,
There's physics and the maths departments, and there are some crossovers with joints, but it's not experimental. And
Right. So yeah, within experimental physics, which really just meant physics, there were no I don't remember any options. I mean, the courses were set. That was it. So yes, I didn't have a stream to choose. I did do my undergraduate here, and I was absolutely determined it was going to be physics. I had no problems there. And then I did decide to do a master's at UCC, which was kind of unusual. And people were saying to me, "Oh, don't bother." They actually turned out to be very good for me. I mean, that might be something worth mentioning. I think one of the reasons I got into Caltech was that they could see that I'd had some research experience. And at that stage in the US, they'd already started having this thing of giving you research experience while you're an undergraduate. So I think it really helped me get in that I had done work with Neil Marcoux before I left Ireland. So I was very happy that I stayed and did a master's. And of course there I did choose the subject. So that was a positive experience for me. To be honest, I only did it because I was very fortunate to get a scholarship when I started at UCC. And at some point I discovered along the way that the scholarship could be extended into doing a master's. So I decided, well, I'm doing a master's then. But at least as much it was because I realized if I have Neil here, why wouldn't I do something with him? Because this is the subject I'm interested in.
perfect. If there are no final questions, we might.
Can I put in one more, if that's okay?
Sure.
So Denise, you mentioned that you're still fairly fluent in Russian. So what have you found helps to kind of stay fluent in a language that you can't be immersed in, let's say?
Wait, can you just ask the question again? I mean,
so what do you find helps to kind of keep up a language that you can't speak every day, let's say?
okay, you want me to freak you guys out? Okay, for a number of years after I left Moscow, like quite a few years, I had some Russian master students basically who were based in Moscow but working with me as their supervisor, coming here over the summer. And sometimes I'd have 3 of them here at a time, working as summer students. So that was helpful. And when the students would have to finish up their masters, they would basically spend their last semester here. So I'd have a Russian student staying in one of my spare rooms. And so that would give me practice with my Russian as well. But the thing that might freak you out is that since like 1995, up until just earlier this year, I was actually the English editor of Astronomiический журнал, which is one of the main Russian astronomy journals, which means that every month I would translate some Russian astronomy articles from Russian into English. So that really helped keep it up. It's not quite the same as conversational Russian. My conversational Russian has gone down just a bit, but many hours of translating astronomy articles from Russian into English was really good for keeping that up. And then, having some good conversation when I see some people at conferences or when occasionally a colleague will visit here.
Thanks.
Following on from Cian's question, how did you find, like, having always done physics through English, how did you find like learning it through a different language, kind of?
Yeah, it was a gas experience really, because I went to Moscow, and I had, one of the things I wanted to do there was work with young people. It was a tough time in Russia. It was like, I went there in the summer of 1993, and then from summer of 1994 to the end of 1998. And, you know, it was a time when, like when I first moved there, you could buy some sort of milk product every day, but you couldn't buy a particular milk product every day. So it might be milk, it might be yogurt, it might be kefir, you know, it might be cottage cheese, but you probably couldn't find, you know, you couldn't find milk every day. So it's fascinating times to live through. But I wanted to work with some students, and it turned out to be really interesting because it was like an equalizer. We did everything through Russian. So like I spoke virtually no English when I was there. It was real immersion. So the students I was working with, like undergraduate students and master's students, they were the ones who were fluent in the language, but I was the one who was fluent in the science. And so it worked as a kind of an equalizer. And we actually all shared one room as well. My desk and the students' desks were all together in one big room. So it was really interesting, and it really helped my Russian get better. And you know, after being there a couple of years, I did get to the point where I could give a pretty competent scientific talk about my research, for example, completely in Russian. And I think at the peak of my ability, I gave a talk at an astronomy conference in St. Petersburg, I think, and I heard later that one of the people in the audience had made a comment to the person standing next to her. Oh, and she has such a nice Moscow accent, which made me laugh. But it was a great experience. If you can have the experience of really going to another place and actually working in the language, it's great. But it's not easy. You have to put a lot of effort into it.
Thanks for those insights, Denise. We're going to wrap it up now. So thank you to Denise and Daniel for your talks. They've been incredibly insightful. And I think we got a lot more mileage out of some of the questions than we were expecting. So thank you for that. And thank you to everyone who attended.
Yeah, thank you very much for having us.
Yeah,
Yeah,
it's very nice to see you all.
Yeah, thank you both. Just before everyone, all right, sorry, I think he's muted now. That's fine. Just before everyone heads off, just for the few events that we'll be doing next week, we have a screening of The Planets by Brian Cox, which should be very good. We're collaborating with the Geological Society on that. And we also should be releasing some rocket footage on our social media, which hopefully the department will be sharing as well, because I know they've been asking for that, so that should be quite entertaining. And as both of our speakers mentioned about how important presentation skills and how important it is to be able to explain a concept, we are working with the Skills Centre for the week after on the November 17th on how to create a presentation and deliver a presentation. So that's something that should definitely be worth going to. And then after that, we'll have our annual physics prize, which is a competition that you enter so you can talk about any physics topic that you want and give a presentation on it to deliver. So that should tie in with the workshop quite nicely. So those are some of the things that we have lined up for the next few weeks. Thank you to everyone.
Yeah, can I just ask you a question? Have you guys ever shown the film, what is it, Einstein and Eddington? Or is it Eddington and Einstein?
I don't think I've heard of it. We can definitely look into
You got to show it.
it.
Daniel.
It's about the 1919 eclipse expedition.
Yeah, yeah.
Well, if it's getting 2 recommendations from
Einstein,
the 2
Einstein and Eddington, David Tennant, you know, Andy Cernak, I think, or whatever his name is for Einstein. And it's probably, well, I know there's certainly some factual stuff in terms of, you know, personalities and so forth. There might be some made up stuff as well, but it's I think you'd probably enjoy it. It's definitely worth a watch.
Yeah, definitely. We can put that on the cards as well, and be something else to look forward to.
You might enjoy it.
And you can watch out for the big astronomy howler right at the beginning. They show the night before the eclipse preparations on the island of Principe by Eddington. There's somebody with him who was not there in real life, so there's a little historical detail. Anyway, they pull back and they show the scene, and there's a big bright full moon. And I'm hoping that you all know that a solar eclipse can only take place at the new moon. So definite astronomy mistake right there.
Well, I'm sure we can make sure our audience are on their toes to watch out for any other possible mistakes when we're watching it as well. So thank you very much, both of you.
If we do
your
decide to show it,
recommendations.
I'm sure we'll send invitations to the both of you, and you can help us along.
Yeah,
Pointing out
excellent.
any
Try to distinguish between real science and fake science.
Yeah, we'll also include a list of factual errors so that everyone who's watching knows what's wrong and what isn't.
Should help with the enjoyment of watching it. Perfect. Thank you very much both again, and for everyone coming. Hopefully we'll see you in some of the events over the coming weeks. Thank you very much.
Yeah, best wishes to all of you.
And you.
Yes, thank you.
Bye.